Hi everyone, my name is Johannes Meusburger and I have just recently started my PhD studies in Karen Hudson Edwards Group at the Camborne School of Mines. In the next 4 years I will work on the characterization of sulfate minerals in extreme environments by coupled Raman spectroscopy, neutron and synchrotron diffraction. I want to study sulfate minerals in particular. First of all, they are of major interest in mine waste management since they are the dominating precipitates from acid mine drainage. In these very acidic waters, they act as scavengers for toxic elements. Sulfate minerals have very different potential to immobilize these elements in the long run. So that's why it's so important to be able to distinguish them for a reliable risk assessment. Since the dawn of space exploration, sulfate minerals have attracted substantial interest also from an astronomical perspective. Kilometric thick deposits of hydrous sulfate minerals have been identified in the equatorial region of Mars. Many sulfates are evaporitic minerals, which typically contain fluid inclusion and hence might be able to preserve bacteria and other signatures of life on Mars over geological timescales. In the end, I want to explain how the combination of Raman spectroscopy and diffraction can help us to identify sulfate minerals in mine waste and on Mars. Raman spectroscopy gives you a diagnostic spectral fingerprint, which is unique for every mineral, and is hence perfectly suited for face identification. A major analytical problem is that you irradiate the sample with a laser, which might alter the sample material, so you can never be sure that the signal you are collecting is the true Raman fingerprint of your sample material rather than the one of a degradation product. But if you perform simultaneous neutron and X-ray diffraction, you would immediately see if the sample degrades or transforms. The major outcome of my PhD will be a database containing the spectral fingerprints of various sulfate minerals and the corresponding crystal structure. So for every Raman spectra that you will find in our database, you can be 100% sure that it's really the Raman spectra of the sample material rather than the one of the degradation product. Once we have completed our database, we want to apply it in mine waste management and space exploration. So our aim is that you will just take such a portable Raman spectrometer into the field, shoot with the laser on a rock, collect a fingerprint and compare it with our database. That will give you the most accurate face identification that is possible. Moreover, both the Mars 2020 as well as the ExoMars rover mission will have Raman spectrometer on board. So they can also use our database in order to identify sulfate minerals on Mars, which are a major water reservoir as well as a prime target in the search of extraterrestrial life.